This is group 23 and we are doing an analysis and redesign of a cordless power drill. A cordless power drill is a portable power tool used in construction, woodworking, and home improvements. Some key features are listed in the slide attached. The cordless power drill operates by converting electrical energy into mechanical energy in order to spin a drill and drill holes through material. The market for power tools is over $20 billion in the US. Massive growth is forecasted, and primary and secondary consumers are listed in the attached slide. In this slide, we have an exploded CAD model of the cordless power drill. All components are categorized and numbered as well as labeled for your review. On this slide, you will see an illustration of the exploded CAD model in effect. A fast diagram was constructed, allowing us to break down a cordless drill into its main functions for further analysis. You can see the diagram attached in this slide. Given the components in a cordless power drill, two assembly sequences were derived to illustrate and improve on the assembly process. Assembly sequence 2 differs from assembly sequence 1 in that we start with the drill shell left before we add in the trigger assembly, and then we add the motor assembly, which is followed by the battery, and after that there's the gear assembly, followed by the chuck assembly, the drill shell top, followed by the drill shell right, and then the drill palm shell, followed by the nameplate to complete assembly. Both sequences were assessed in a sequence comparison table. Assembly sequence 2 scored higher due to an improvement in terms of ease of handling, ease of access, as well as overall assembly time over assembly sequence 1. A functional component mapping matrix was constructed in order to understand the impact of redesign as well as potential for creating a product platform due to modularity. A bill of materials was constructed in order to understand cost of manufacturing and assembly before applying DfM to improve the design. Total cost was as certain as $307. Functions were further analyzed to identify which ones differ when creating a variety of product offerings. The reasoning for these differentiators was determined from looking at needs for primary customers and secondary customers. The functional differentiation table is attached in the slide and illustrates these differences. In a component comparison table, we determined which items were platforms and modules in order for a new product offering. We then categorized the components in a power drill to identify opportunities for reducing cost in the high cost, high functional importance box in the diagram attached. The gear assembly, chuck assembly, battery, and motor assembly will fall into this area. For design for manufacture and assembly, we will primarily focus on the gear assembly, the chuck assembly, and the battery. Design alterations were explored for the modules we identified. Firstly, we looked at gear assemblies to vary speed and torque for different applications. As you can see in the images attached, we identified 3 modules, each with varying gear ratios, which range from low speed, high torque, all the way to high speed, low torque. High torque, low speed would allow for drilling into harder materials, whereas high speed, low torque would allow drilling into softer materials. Secondly, we looked into a keyed chuck to go with a keyless chuck offering more compatibility with accessories. The keyed chuck would allow users that require more access and more usability with existing components and accessories that they already have. In this diagram, you will see some of the designs that we're considering. Lastly, we are considering a high-capacity battery in order to cater to customers that require heavy use and more hours from their cordless drill. The first module features an 18-volt 2 amp-hour battery in comparison to Module 2, which has a larger amperage-hour offering, allowing for longer use time. With modules in place, product family assembly diagrams were constructed to show potential variety and opportunity for delayed product differentiation. In comparison to Assembly Diagram 1, Assembly Diagram 2 delays branching to the fourth step in the assembly process, whereas Diagram 1 branches on the first step.